Welcome, ladies and gentlemen, to the technical forum of the group exhibit Hydrogen Fuel Cells and Batteries. We have all day long very interesting presentations about this new technology. And if we talk about fuel cells, if we talk about batteries, we also have to talk about the materials that are inside it. And the next presentation will be about the material, about porous metal, characteristics and advantages for use in alternative energy applications. And we have a gentleman here from Connecticut, USA, who will talk about that. The technical sales engineer applications engineering of Mott Corporation, Robert Saunders, who is, by the way, also a professional lead singer. But he said, well, maybe he sings something. I'm looking forward to that. Robert, good to have you on stage. Come on. Here you go.
Thank you. Thank you.
Thank you.
Okay. Thank you. Yeah. As you mentioned, I've sang a few songs here and there. I tried to find something that was applicable that I know that would be good, but couldn't come up with anything, so I apologize. All right. So anyway, thank you. I'm, as you said, I'm Robert Saunders. I'm with Mott Corporation. Mott Corporation is a porous metal manufacturer and integrator of porous into components for high precision filtration and flow control. We're located in Farmington, Connecticut, and we're happy to be here presenting with the Fuel Cell Coalition of Connecticut. Thanks to that group for everything that they've done so far. Okay, so basically, Mott Corporation is, like I said, a high precision filtration, flow control company. We integrate porous metal into components for various different applications. And a lot of these applications are in the alternative energy field and other industries. Some of our specialties are gas diffusion layers. We make those out of various different materials, titanium, 316, 430 stainless steel, nickel. Static flow controllers, that's basically a porous element which is tuned to a very specific flow for a given differential pressure. And it's great for flow control. Filtration, the material that we manufacture is a very good filter. So we tightly control the pores, and we'll get into that in a little bit. Gas liquid contacting, sparging is another application that we typically use our material for. That's any process basically that allows for a gas to be diffused or absorbed into a liquid. This could be a chemical industry, this could be food and beverage, this could be some sort of humidification applications, etc. You also have heat transfer, fluid wicking. The material is also good for flame arresting for flammable gases to prevent backflash. That's typically used in that application as well. And a variety of other applications. And I would challenge the engineers at this here to come up with other applications. We'd be glad to take a look at them and evaluate them and help you with a solution. Our products come in various different alloys. I touched on a few of those. It also can be coated with surface treatments and catalytic layers that will help the performance. It also it can be customizable, meaning the geometries, the assemblies can be customized. We do a lot of that type of work. Okay, the basic process on how our material is formed is we start out with a powder. And it's basically a pre-alloyed powder. It goes through one of three forming processes. One of them is a proprietary roll process to create sheet. And two other processes, basically axial pressing and isostatically pressing components into various different forms. Once they're in a green state, then they get sintered, and they're sintered in a tightly controlled environment. The result is a tightly controlled porosity. There's a pore size distribution, and if you can see the differences in pore size here, it can range from 0.2 micron all the way up to 100 micron. Now there's a pore size distribution. It's not a fixed pore size. It's not it's not a fixed pore size. There's a pore size distribution associated with it. Okay. The resulting components are tightly controlled porous components in the forms of tubes, cups, and sheet, as we discussed. I'd like to talk a little bit about the sheet material that we manufacture. The sheet material that we manufacture it provides a very tightly controlled, uniform pore size. Not necessarily pore size, but a pore size distribution evenly distributed across the surface of the material. This provides for a very even flow characteristics across the material. Uniform thickness. The thickness can range plus or minus 0.001 inches. So it's a very even and flat, uniform thickness. The corrosion-resistant materials that we provide, I've touched on some of those, titanium 316 and others. We can go into those details. If you have any questions regarding materials, then we can please visit us at D33. We also have a broad range of thickness and porosity. The thickness of our material can be as thin as 0.25 millimeters and as thick as 1.5 millimeters, with porosity ranging from 15 to 50%. Other benefits. Strength. It's a very high strength material. It's ductile and machinable, so you can create features with it. It's weldable, so you can weld it into assemblies. It's electrically conductive, which is the advantage of use as a gas diffusion layer, and also maintains the porosity under strong compressive loads. And that's another characteristic which is very advantageous for our material. So it's got a very smooth surface, so that makes for it to be easily coated or plated. And it makes for a strong catalyst substrate. Some of the applications that we've either come across or where a material has been confirmed in the use of, or I would challenge some of the engineers to take a look, and these are some suggestions that maybe might fit into your application. So you have gas diffusion layers, catalytic support substrates, flow restriction, the flow restrictors for even gas distribution through your fuel cell, or etc. Battery applications, porous electrodes, heat transfer plates might be another application as well. Hydrogen generation. As I mentioned before, the material is smooth. It's easily coated with a catalyst. So coating this with a palladium membrane or such, using this as a support substrate is another option as well. Also, hydrogen storage. Use of the material as a retention element for some hydrogen storage materials. Ethanol. As far as sparging, we mentioned sparging. Sparging, as I said, was the introduction of oxygen or some gas into a process. One of the other applications that we see quite frequently is sparging of oxygen into fermentation process, and or into yeast for oxygen into a yeast propagator. Nuclear applications, dewatering of nuclear waste, radioactive liquid waste, and that's why we're all going to clean fuels, right? To get away from some of this. So biodiesel filtration is another application. As I mentioned, our material is a very good filter. So I'd like to ask for any questions.
First of all, you get the applause of the audience. Thank you, Robert. Very nice presentation.
Yeah, thank you.
Yes, of course. Whoever has a question, please raise your hand, and I'll be with the microphone right with you. Any questions so far about porous metal? Well, I would like one thing from you, Robert. I've learned there are only 3 problems in the fuel cell technology industry, and the 3 problems are costs, costs, and costs. So can you contribute to solving that problem a little bit? Have you got cost targets for porous metals?
We have cost targets for cost reduction on our end. We are working to improve our processes so that we can improve those cost efforts, or that pricing to the industry.
And what will the target be? So how much less could you?
Yeah, there's a little bit more. You're trying to get me to commit to. I can't tell you what that is because I don't know exactly what the cost target is. We are in the process of doing the cost reductions, so we'll move forward with those, and then as we go along, then we'll roll those out.
Okay. Any question from your side? Yes, there's one, Mr. Wirkert.
Yeah, hello. You mentioned the application as a gas diffusion layer in fuel cells.
Yes.
Is it also? What do you think of the permeability for fluids, especially water? Is it also possible to get water through your titanium porous metal?
Yeah. Well, first of all, I'm a porous metal expert, not a fuel cell expert. So, I'll try to answer your question the best I can. We can control the porosity of the material. So, the range of the pores to create the optimum size of the pore. If you have in mind a specific pore size that you need for the performance to be exceptional in your fuel cell, or even electrolyzers, or et cetera, then we would target that. Okay, so it's variable. It's not a fixed pore size. We can do a range given within the geometry of the sheet, the thickness, etc.
Would it be possible to have a gradient of porosity? Let's say small porosity at the surface and big porosity or large porosity in the middle of a sheet?
Yeah, we have done a little work with that, and not a actual transition or gradient. We've done a little work with it. We haven't created that into any specific product, but it's something if there's something that you think that would be beneficial, then perhaps we can take a look at that. Yeah.
Thank you for that question, Dr. Wirkert. And any other questions from your side? Please raise your hand if there's one. Not at the moment. So I would like to thank you once again, Robert, and just advise everybody to go to your booth. It's just over there, D331. Thank you for the excellent presentation, and I'm looking for next year when you're going to sing.
I'll prepare a song for next year.
That would be great, indeed, yes.
Thanks.
Okay, everybody, please stay tuned. In just 6 minutes' time, we have the next presentation here on stage. Will come from Dr. Paul Lichty, CEO of Pneumatic Coat Technologies from Colorado, United States, about high-volume ALD coating of lithium-ion material, improve safety and versatility. So I'm looking forward to that presentation in only 6 minutes' time. Thank you.